Lab 5 this week deals with molarities, and molarities are a way for us to report different concentrations of solutions. Molarity is defined as moles of a compound per liter of a solution, so make sure that you know it's not per liter of solvent, but per liter of solution. And molarity is reported in moles per liter, so capital M. So we know that it's often necessary to prepare solutions of known concentration. And there are two ways to do this. The first is to prepare a concentrated solution and take some of that to prepare a dilution. So we can use the equation of C1V1 equals C2V2 to determine how much of a concentrated solution we need to prepare a diluted solution. So in this equation, C1 and V1 are related to the concentrated solution, where C is the concentration and V is the volume, and C2 and V2 are related to the diluted solution. So we have to make sure that our V1 and our V2 are both in either milliliters or in liters. Another way to prepare solutions of known concentration is to use pure solute in a given volume. So what we would do in that situation is figure out how much of a solid we need, to convert that to moles of a solid, and then use the molarity, or vice versa. Now let's practice using method 1. So the problem is that we want to prepare 500 milliliters of a 1 molar sulfuric acid solution from 18 molar sulfuric acid. So the question we're trying to solve is we want to know how much of our concentrated acid we're going to have to use to prepare our dilute acid. To solve this problem, we can use C1V1 equals C2V2, where C1 is the concentration of our concentrated acid, so that's 18 molar. V1 we don't know, that's what we're trying to figure out. C2 is 1 molar and V2 is 500 milliliters, and we're given that in the problem. Now we can just simply solve for V1. So we multiply 1 molar times 500 milliliters, divide by 18 molar, so we get V1 equals 27.7 milliliters. So notice that the units of V1 and V2 are both in milliliters. It's very important that you stay consistent with your units between the two problems, so you wouldn't just put in V1 in liters or V2 in liters and expect the answer to be given in milliliters. You always get the same units for volume. So what this problem is telling us is that if we use 27.7 milliliters of concentrated acid in a 500 milliliter volumetric flask and we fill to the line with water, our final concentration in that flask will be 1 molar. Now let's practice making a solution of known concentration using the solid, so method 2. So the problem is that we want to prepare 500 milliliters of 0.0250 molar potassium dichromate starting with the solid. So the first thing that we need to do is determine how many moles of solid we need. So the way that we do that is we multiply the volume of solution, so 500 milliliters. We want to convert that to liters since molarity is always given per liter. So times 1 liter per 1,000 milliliters. And then we multiply that again by the molarity to cancel out liters and solve for moles. So we multiply that by 0.0250 moles per liter. And from that we get that we need 0.0125 moles of potassium dichromate. So now we need to convert moles of solid to grams of solid, so we can use the molar mass of 294.2 grams for potassium dichromate, and we get that we need 3.68 grams of potassium dichromate to make this solution. So the way that you would do that is you would take 3.68 grams of solid, put it in a 500 milliliter volumetric flask, and fill to the line with water, and you've made your solution. Another way for us to determine concentrations of solutions is to perform a titration. So a titration is a special type of stoichiometric reaction, and in a titration, two reactants are combined until there are equal moles of both. So our goal is to figure out how much reactant is needed to completely react with a second reactant. So typically in titrations, we have an acid and a base, and we want to know how much acid is needed to either fully neutralize a base or how much base is needed to fully neutralize an acid. So the procedure for the titration is you fill up your vat with titrant, so that's your reactant number 1. Then you add reactant number 2 to a flask and add a few drops of indicator. So the indicator is what changes color at the equivalence point, and the equivalence point is when you reach equal moles of reactants. So it's hard to see visually, usually without an indicator, because most solutions that we're going to use for titrations are colorless. But when we have the indicator there, we'll clearly tell when all of both reactants are used up. So the last step of a titration is we're going to add the titrant until we reach the indicator color change. And we're going to record the volume that we used, and that volume can be used to calculate a number of different quantities. So the goal of titrations is to use the volume of titrant that we added and its concentration to determine the concentration of reactant 2. Let's practice solving a titration problem. So the question is, what volume of 0.2010 molar sodium hydroxide is needed to neutralize 20.00 milliliters of 0.1030 molar HCl? So there are 4 steps to solving titration problems. The first is that we want to write a balanced equation to figure out the mole ratios of reactants in the equation, in the problem. The second thing we want to do is determine the moles of HCl in solution, because we're given both the volume and the concentration, so we can get moles. Then we can use moles of HCl to determine the moles of sodium hydroxide, which is our titrant, that we're going to need to completely neutralize the HCl. And then we're going to determine the volume of the solution using the molarity. So the first step, we're going to write out the balanced equation. So NaOH plus HCl gives NaCl and H2O. So if we look at that, it's balanced, so we can move on to the next step. So we want to determine the number of moles of HCl. So we know that we have 20 milliliters of HCl because we're given that in the problem. We can convert milliliters to liters easily, and then we can convert liters to moles using the molarity of the concentration. So 0.1030 moles of HCl per 1 liter. And we get 0.002060 moles of HCl. Now we can convert moles of HCl to moles of sodium hydroxide. So we know that we have a 1-to-1 mole ratio of sodium hydroxide to HCl, since we have that from the equation. So 0.002060 moles HCl times 1 mole HCl per mole, 1 mole NaOH per mole HCl, and we get 0.002060 moles of NaOH. Now that we have the moles of NaOH and we know the concentration from the problem, we can convert to volume. So we have the moles, we multiply that by 1 liter per 0.2010 moles of NaOH, and then we convert that to milliliters, and we get 10.25 milliliters of sodium hydroxide. So we need 10.25 milliliters of base at 0.2010 molar to neutralize 20 mils of 0.1030 molar acid. What sometimes happens in titration problems is that you either have 2 protons that need to be neutralized in an acid, or you have 2 hydroxide ions that need to be neutralized in a base. So when this happens, it's really important to take note of the mole ratios of ions that we have to neutralize so that we can solve the problems accurately. So let's practice this situation. So if we have a 10 milliliter sample of calcium hydroxide, and we know that it requires 23.30 mils of 0.02 molar nitric acid to be neutralized, what is the molarity of the calcium hydroxide solution? So as before, we need to write a balanced equation for this reaction. So we have 2 HNO3 plus calcium hydroxide gives us 2 water molecules and a calcium nitrate. So we see that for every mole of calcium hydroxide that we have in solution, we need 2 moles of nitric acid to neutralize it. So the first thing that we want to do is convert the volume of nitric acid to moles of nitric acid so we can solve for moles of calcium hydroxide. So if we have 23.3 milliliters of nitric acid, we can convert that to liters, and we can use the molarity to solve for the moles of nitric acid, so 0.02 moles of nitric acid for every liter of nitric acid, and then we can use the mole ratio of 1 mole of calcium hydroxide for every 2 moles of HNO3. And we get that we have 2.330 times 10 to the minus 4 moles of calcium hydroxide. Now we can take the moles of calcium hydroxide and convert that to molarity using the volume given in the problem. So we know the moles, we know that we have 10 milliliters of solution, and we know that molarity is given in moles per liter, so we have 2.330 times 10 to the minus 4 moles of calcium hydroxide per 10 milliliters. Then we convert milliliters to liters, and we get 0.02330 molar calcium hydroxide. So that's the concentration of our unknown solution.